All right, today we're going to be talking about the remainder theorem. So we're going to evaluate functions using synthetic substitution, and we're also going to determine whether or not a binomial is a factor of a polynomial using synthetic division or synthetic substitution. So here's our first key concept. If a polynomial is divided by a factor and the remainder is a constant, that constant is the same thing that we would get if we did a function notation. So if we put that number in and multiplied it out, it would give the same thing as if we get the remainder when we synthetic divide. Let me show you. All right, so here we have 2x to the fourth minus 5x squared plus 8x minus 7. Now if I take 6 and put it into the box, so we're going to do the synthetic substitution. This is what the theorem says. So if I put 6 in the box, remember there's no x cubed, so I got to put a 0 there. So 2, 0, negative 5, 8, negative 7. And I go ahead and do this whole thing. I get 2,453 at the end. Now, what this is saying is if I do f of 6 and put 6 into this equation and solve it that way, I should also get 2,453. And let me show you. If we actually just substitute it in, 6 to the 4, 6 squared, we actually get the exact same answer. This is really important for the things that we're going to be doing this week. Whatever we get here as a remainder is also the value at that point for the equation. So as we're going ahead and figuring this out, this polynomial here has a order pair of 6, 2,453. That's what this means. So when I put 6 in, that's what I'm going to get as an answer. So as I'm doing the synthetic dividing, no matter what value we get here, we know that that's actually an ordered pair for this polynomial. And we'll use that in conjunction with some of the other things that we've done in order to go ahead and solve polynomials. And that's what this factor theorem is about. X minus r is a factor if and only if the remainder is 0. So we're going to go ahead and do some synthetic division in order to go ahead and find the factors. Now today, what's going to be nice is they're going to tell you which one to try and see if it is a function and go ahead and get all the factors that way. Later on in this week, we're going to go ahead and do it ourselves. We're going to have to find our own factors. All right, so let's see what a problem is. Determine whether or not x minus 3 is a factor of this polynomial. And then we need to find the remaining factors. All right, so x minus 3, we're going to plug it in. So because of the minus 3, we're going to put 3 in the box. We're going to have 1, 4, negative 15, and negative 18. Drop the 1, multiply, add, multiply, add, multiply, and we got 0 as an answer. That means that it is a factor. So now we need to find the remaining factors. So we look at what we have left. We have 1x squared plus 7x plus 6. So we have this one factor, x minus 3 on the outside, and then this on the inside. Well, this is a binomial that we can a trinomial that we can go ahead and simplify. We're looking for two things that multiply to 6 that add up to be 7. Well, that's 6 and 1. So that factors into x plus 6 and x plus 1. Now we add that x minus 3, and that is what this trinomial is factored out to be. These then tell me my solutions. My solutions, because of the zero product property, would be 3, negative 6, and negative 1. And if you look at your graph of this equation, you didn't have to graph it, but if you did look at the graph of this equation, look at our solutions, negative 6, negative 1, and 3. Those will line up. So if we can break down any polynomial into this form, we should be able to find our zeros. And we're going to use that idea throughout this week. All right, let's try another one. Is x plus 2 a factor? So we write so it's x plus 2, so we write negative 2. 1, 8, 17, 10. Bring down the 1, prime the pump, get it going. Negative 2 is 6. Negative 12 is 5. Negative 10 is 0. So 0, it works. So what do I have left? I want two numbers that multiply to 5 and add to 6. Well, that's 5 and 1. So I have the 5 and 1, and then bring down the x plus 2. You could have these in any order that you want. It's okay. What does that mean for my graph? Well, for my graph, it'll cross at -1. It'll have a 0 at -1, -2, and -5. All right, what about this one? Again, +2, so we do -2. 6, 11, -14, -24. 6 is -12, adding it is -1, then 2, -12, and we do get the 0. So now we have 6p squared minus p minus 12. Now, because we have the number here, we can't just do it normal. So we're going to have to split it and make it a grouping. But we still do 6 times -12 is -72, and we want it to add up to be -1 on the bottom. So what does that? Well, that's -9 and +8. So then we put the -9 and the +8 in there. Looking at the first two, we can take it out of 3p. And we're left with 2p minus 3. Out of the next two, we can take out a 4, and we get 2p minus 3. The 3p plus 4 comes out in front, and the 2p minus 3 is in the back. So we have those plus the p plus 2. And if we multiplied all of this out, we would get back to this original problem. And that's what I have for you today.